Okay, so let's do in class 10, number 1. So it says, in general, women's foot lengths are shorter than men's. Assume that the woman's foot lengths follow a normal distribution with a mean of 9.5 inches and standard deviation of 1.2. Also assume that the men's foot lengths follow a normal distribution with mean 11.5 inches and standard deviation of 1.5. So question A, suppose Joe's foot length is 13.25 inches and Maria's foot length is 11.6. Which of the two has a longer foot length or foot relative to his or her gender group? So let's look at the z-scores for each person. So let's look at Joe's first. So Joe's z-score. So again, the z-score is going to be his foot length minus the mean for the men, which is 11.5, divided by the standard deviation, which is 1.5. And like you check, if you work this out, you get 1.167. Now let's do Maria's z-score. Okay, so Maria's foot length is 11.6 and the woman's mean is 9.5 inches. 9.5 divided by standard deviation for women, which is 1.2. So 1.2 goes here. And if you work this out, you get 1.75. So note then, note Maria has a larger z-score, which implies her foot length is larger relative to her gender. Okay, so let's do part B now. Part B. What is the probability that a man has a foot length greater than 9.5 inches? Okay, so we're looking for then probability that X is greater than 9.5. Okay, so again, this is for the men's normal distribution, so we have to change it to a standard normal. So we'll do the z-score. So it'll be z greater than or equal to it'll be our z-score here. So 9.5 minus the mean for the men. So the mean for the men is 11.5. So minus 11.5. So 11.5 over standard deviation for the men, which is 1.5. Okay, and working this out, probability then z is greater than or equal to, so if you work that out, it becomes negative 1.33. And I claim this will equal then 1 minus probability z is less than or equal to negative 1.33, and I'll explain how I got that. Okay, so looking at a normal distribution, standard normal here. So we're looking at the probability z is greater than or equal to negative 1.33. So this is standard normal. So the middle would be 0. So negative 1.33 would be over here somewhere. 1.33. So we're looking for the area to the right. So I claim that will equal, draw another normal distribution here, another standard normal. The total area under this curve but the total area under a normal distribution is always 1, so this guy would equal 1. And then from that, we're going to subtract understand a normal distribution here. This time we're looking at the area to the left of negative 1.3. So that'll be probability z less than or equal to negative 1.33. And this guy we can get from the z table. So that's how we got this. So this will equal then 1 minus that. Because you can see if I took away the tail here, so let's say this is a negative 1.33 here. So if I took this away over here, I will have this picture. Okay, so let's keep going. Okay, so I just noticed here there should be 11.5 right there. Okay, so now to keep going with this question, we have to now go to our table. So I'm going to click on the z table right here. Okay, so here's my z table. Let me make this a bit bigger. So if we go back, we're looking for negative 1.33, this guy here. Okay, so looking at our z table, for that value, let's go up here. So our negative ones are on this side. Okay, so we're looking for negative 1.33. So here's negative 1.3 right here. So let me mark this. So negative 1.3 starts here. I'm going to go all the way over until we get to this one, I believe. Okay, I need to go up here a bit. Yeah, this is the 3 column here. 1 second here. Okay, let me redo that a bit. Let's actually move this up a bit. There, okay. So now I'll do it. So we're going down we're going to negative 1.3, going across, and then coming down from 0.03, because the number is negative 1.33. So it's going to come down here. So that guy right there will be our number. Okay, so let's put that over into our Google Doc. Okay, so number will be basically equals then 1 minus 0.0918, which equals then 0.9082. Okay, so we're done with part B. Let's go on to part C. So part C, let me move this to down below here. So part C says what is the probability that a woman has a foot length less than 11.5 inches? Okay, so let's insert equation. So we're looking for probability x now, but it's now the woman's less than, so less than or equal to 11.5. Okay, so we have to do z-score on this. So it'll be then 11.5 minus woman's mean. So we go up the top here. Woman's mean is 9.5, so minus 9.5. There's 9.5 over, oh sorry, I forgot my z in front here. Over, I'll put a z in a second there, over the standard deviation for women, which is 1.2. So over 1.2. Okay, let me add in my z here. Okay, so I've added my z there. So doing this calculation, you'll see it's, let me add here, so equal then probability z less than or equal to, so if you work it out, it's 1.66, keeps going. Since the table, the z table is good to 2 decimal places, we're going to round it, so it'll be 1.67. Okay, so now we can go to our table to find this. So let's go back to our z table. So we're looking for 1.67. So let's go back to our table. So this is positive this time. So 1.6 is here. 0.7 is over here. So that's so 1 point going off 1.6 all the way until I get to the 0.7 column and come down. What's that guy there? 0.9525. Okay, so let's put that into our table, 0.9525. Okay, so 0.9525. 9525. So we're done with that one. So let's go on to part D. Well, I think actually I'm going to do part D and E in the next video, so let's leave it here for now.